Well, I think one of the most important things we can do in science is to just show where all the formulas come from that we see in a textbook. This is, I just call it, seeing how the language of math applies to science. And this is a very critical point to me. And I just wanted to take and show you a simple little experiment that we do. Let me show you the equipment. And here is our setup. It couldn't be much simpler. It's just we're boiling some water. We have 2 thermometers in it. I don't know if you can tell, we have 1 Celsius, and that's the blue thermometer, and the red thermometer is a Fahrenheit. And we're just going to take readings as we boil the water. Well, now what we do is we just plot some numbers as we boil the water. And I've already taken a few temperatures here to plot. We have, when it was 20 degrees Celsius, it was 68 degrees Fahrenheit. When it was 40, it was 104. And when it was 60, it was 140. So what we've done is we've taken data and we've just plotted it on a data table. Now, where do those formulas come from that I see in a textbook? I always see formulas in a science textbook, and one very important concept I like to hit with students is they all come from experimental data. Now, let's just plot this. And 0 degrees Celsius is 32 degrees. I put that point right here on our graph. 100 degrees boiling point is 212. I put that point right here. And then the other ones, again, we would plot this much more accurately than I'm doing it. I'm just trying to show you the principle here. But we have plots for the 20 degree mark, the 40 degree mark, the 60 degree mark. And if I did this a little more accurately, what you would see is this. This forms a nice straight line. And the beauty of finding, that's called a linear relationship, but the beauty of finding a linear relationship is we can make a mathematical statement out of that. What does our algebra teach us? Our algebra teaches that the basic equation for any straight line is y equals mx plus b. And what do we do in science? Well, in science we just say, I plot Celsius here, Celsius here, Fahrenheit here, let me erase that. We say, let's turn this general equation into the specific equation for this experiment. So what did I plot on the y-axis? I plotted Fahrenheit. We're going to say that equals m, which stands for the slope of the line, times what I plotted on the x-axis, which will be Celsius, plus b. Now, I'm just going to walk through this step by step. What's the plus b? Well, hopefully algebra has taught us that the plus b is where it crosses the y-axis. And this time it crosses the y-axis, the 0 point on the x-axis is 32 on the y-axis, so I'm going to put here f equals m times c plus 32 because that's where it crosses the y-axis. Now the last and probably the most important point in this one is, what's the m value, or what's the slope value? Now I'm just going to take our furthest 2 points apart. You could take any 2 points here and get it, but probably the easiest is, I'm going to drop this line down here, drop this line down here, and remember, slope is change in y over change in x, so we're just going to calculate how much y changed and how much x changed. Now, y went from, this is 32 here, and 212 up here, so y, 212 minus 32, the change in y was 180 degrees. Change in x is nice and easy. Started at 0, went to 100, so the change in x is 100 degrees, and we will put here f equals 180, that's change in y, over 100, that's change in x, plus 32. Now, we can reduce this. We can reduce it to 18 over 10, and 18 over 10 can be reduced to 9 over 5c plus 32. Now, this is an equation. Most students see in their science textbook and have no idea where it comes from. What I like to emphasize is every equation that we find in our science books comes from experimentally getting the data, graphing it. If it's a nice linear relationship, then just working an equation right from that. That's how all the data and equations in our science book, that's where they came from. I hope that helps. Have a great day.